we had on page 10, contract reviews 1 through 3. Good job, that's a perfect heading. I'm still working with junior high, I just want to get that heading.
Really?
Well, that's because different teachers do it a little bit differently, so just help me kind of with that. Alright, you want to have one blank line, so almost perfect, but everything else looks good though. Yeah.
Well, I need to leave my phone out.
Yes, because we're gonna go over it, so don't just like put it away. Like once I check it, like I've checked it, but you need it just in case I call on you. And since there's only 2 of you, you're gonna get called on.
Why don't we, I'm curious, why don't you do homework like right after you check it and then they study with this? Why?
Because I want you to use your time instead of everyone just sitting around while walking around, depending on the class size. Like for junior high, there's 7 or 8 of them, and so because of that, I don't want them to just be chilling out. So this is so that way you can be studying and be ready to go. So it helps you kind of get ready for it. What?
This is your smallest class?
Not the smallest class ever.
You had 1 kid once?
No, I had 2 kids one time as well. So this is like your time for the smallest class ever. But I mean, technically, there's 4 of you. Just Quentin and Jamie are not present in the class, but technically, there's 4 of you. All right, so we got to go over what these are as well really quick. All right, so green slip. You know what these are. You probably heard this in the last class already as well. But if you get an incomplete homework, or if it's not done properly, or if it's not readable, or if it's not done in black or blue ink, or if it's not done in pencil, or if you decided, you know what, YOLO, I'm going to do it in red and I'm going to write it messy. You're going to have to redo it. So, the green slip, you fill it out, I'll give it to you. So, you're going to write your name, the class, this is chemistry teacher, hope you know who I am already, the date. Now, you get to choose a reason telling me why you didn't do it. Now, these are not excuses, you're just telling me. You could put the first one, I chose to not complete it. Okay, thank you for being honest, but you're still in trouble.
Because Miss Morris is mean.
No, because I'm trying to help you learn.
Yeah.
So that's part of the reason why I do homework, is to help you learn as best you can. Or I forgot to complete it. Again, not a good reason, but it's honest. I copied the assignment incorrectly. Okay, now you know for those, if you did the wrong section, like I even had that in junior high this morning, where some of them just did the wrong sections, because again, they're not in their meetings and they do the wrong section. And that's okay. So, how many times did you do the wrong section last year in biology?
I got like 16 homework right every year.
Okay, but anyway, it's to help them so that way they can show it to me the next day. Now last year I made you show it to me on the same day. Okay, this year I'll be a little bit nicer and show it to me the next day, but you better have it with you the next day. Otherwise, just kind of the homework again.
Can we show it to you?
Wait, raise your hand. Because I gotta go through this. Okay.
Can we show it to you the same day?
Yeah, if you want to, it's fine. But depending on when you do it, like for junior high or physical science, that's like the last class for them, and then they have PE, they don't have time. So that's like it gives you a little bit extra time for it. Alright, I completed it, left it at home. Sometimes life's just unfortunate, so bring it the next day, but it still counts as a homework defense. I didn't have what I needed to complete it. You might realize once you got home, you used your calculator, and you forgot. So that's part of the reason as to how come you're saying, okay, I didn't have it, I tried, but I just forgot, I wasn't prepared. So that's how come you want to check to make sure, okay, I should probably throw my calculator in my bag, but today we're using your calculator. So if you realize right now that you need your calculator, you may go get it really quickly. But yes, we're going to use them today in class.
Right now,
Careful
my
when you...
calculator's out of order.
What?
My calculator's
You
out
can
of
borrow
order.
mine then, that's fine.
Because they're still trying to fix it. They're trying to get a battery, but yesterday they got a battery for it and it didn't.
Okay, you can borrow my calculator once we get to that section. Wait, where are you going?
No, I was about to.
Okay, oh, okay, you don't need it right this second for it. But yes, thank you for trying, I'm trying to get it. Is Mr. Nadasky helping you out with it as well?
I told him about it, but we didn't really need it at first. So.
Yeah, it's okay. We started kind of fast in here, so I'll let you just borrow my calculator because I checked it all yesterday and it still works fine. So you can just borrow mine for the class.
Should
Okay.
have it by tomorrow, but
Alright, so let's go over, while Chris is doing his thing, I'll let you go ahead and start. So concept reviews on page 10, 1 through 3. So number 1, what has to do with the closest of measurement to the true value? What term refers to that?
accuracy.
Good job. Alright, what's your complete sentence say? Just finish the practice.
Accuracy has to do with the closest of measures to the true value.
Good job. Alright, what are the 2 main types of exact numbers? Chris?
Metric and FPS.
Oh, you're doing asking the system measurements. Okay, so those are two system measurements. It's asking them what are the two main types of exact numbers. How do we know that you have the exact state? How do you know that you have these numbers exactly? All right, Ethan, what did you have?
That's what I had, system event.
Okay, just be careful. Your book does have a section where we talk about exact numbers. So I know sometimes all the terms get a little bit confusing. So just be careful as you're going through it. There are two types of exact numbers. Counted numbers, if you can count, like I can count the number of desks or the number of students in my class. And I know there are 2 students present in my class with me. I don't have to wonder, are there 2.5? Are there 1.5? No, I can count. There are 2 students in my class present with me right now. So that's an exact number. The other one is defined values, like how many centimeters are in a meter. Anyone know just off the top of your head?
Wait, what?
How many centimeters are in a meter?
60.
1,400.
A meter with a centimeter. How many centimeters are in a meter stick?
10,000. 1,000.
It's okay, we're gonna go over this today, but there's 100 centimeters in a meter stick. Alright, so let's pick a little bit easier one. How many inches are in a foot? 12. Okay, you don't have to wonder, does this foot have 11.5? Okay, by definition, there's 12 inches in 1 foot. So that's the idea of a defined value. Alright. Number 3, name the basic units of length, mass, and volume. Alright, we'll split these up so that way it's a little bit easier. Alright, length, Chris. Good job. Alright, mass, Ethan. Kilogram. Alright, and then, or gram, either one works. And then volume. Liter. So if you see liter in a word problem, it's referring to volume. If you see gram or kilogram, it's referring to mass. If you see meter, it's referring to length. They don't ever swap those up to mean other things. That's why that's super critical. You need to memorize them right now. Alright, you can go ahead and put out your homework away. I would recommend though that you have a piece of paper out so that as we're reviewing loosely, super quick, that if you realize, I don't know these terms, it's dated too, but you should still learn them and you should still be working on them. Go ahead and close up your textbooks though, so that way there's no cheaters as we're reviewing. So that way, though, it'll help you to review. So make sure you have a piece of paper and a pencil. Did you have a question, Chris?
Oh, I was just saying.
Alright, make sure you raise your hand though, because you're closer to the camera or the microphone than I am, so they can actually hear you better than me. So make sure if you have any questions or anything that you need to raise your hand before it. Alright, so thinking back over it, what is the branch of science that deals with the study of composition, structure, and properties of matter and the changes that matter undergoes? What do we just call that, Chris? Yep, so chemistry, know the basic parts of it. Alright, there are 5 parts of chemistry. Which one deals with applying the theories of physics to the study of reactions and properties of matter? Ethan, you know? Alright, Chris, you're obviously the backup.
Okay, I said physical chemistry.
Physical chemistry. Alright, what if it's chemistry where it studies carbon? Or, what was it? Organic. What if it's not studying carbon? Inorganic. Inorganic, good job. What if you're studying the chemistry of life? Biochemistry. What if you're studying chemistry where you're trying to analyze or break it into pieces?
Analytical chemistry.
Analytical chemistry. Alright, that was pretty much all. We talked about the different careers of chemistry, but you don't need to know those specifically. We did talk about the scientific method. There are 3 basic parts to the scientific method. What is the first one? I think I left off with Ethan, so we'll just go over to Chris.
Make a hypothesis.
Oh wait, you gotta do something first before you can make an educated guess. Yeah, so observation or observing, you have to look at the world around you and observe first. What's the second major step? Ethan? Hypothesizing. That's whenever you can make an educated guess now, because you've observed the world around you or you've done research. And then what's the last major step? Chris? Close. What do you have to, if you're going to analyze?
Conduct an experiment.
Yeah, you have to experiment or experimenting first. I think that's where we pretty much left off yesterday. So do make a note of the 3 major steps. You don't have to note like the 6 steps like how you learned them last year in biology. You don't have to do that anymore. Just make note of these 3 major steps: observing, hypothesizing, what a hypothesis is. Oh, what is a hypothesis? I skipped that. Ethan.
Do what?
What is a hypothesis?
It's a guess.
Good job. An educated guess, or a best, or an unproven idea. That's how your textbook sometimes puts it as well.
I thought unproven idea was a theory.
Okay, remember, if you have a hypothesis and it passed multiple experiments, what does it become? A theory. So a theory is kind of like the mentioned word. Okay, it hasn't been around a whole lot.
Then there's law.
And then there's law. So yeah, we're gonna get to this. Alright, I put these down here, they're kind of half hidden by my little like PowerPoint there. Your book doesn't really talk about, I tried to check out the updated terms for it, so I'm just telling you since your book just describes them as just the variable and the constants. Technically, it's the independent variable and the controlled variables. So these are just your constants. Now, thinking back to your STEM project last year, how many independent variables could you have in an experiment? Anyone remember?
Yeah, one.
One, only one. Everything else had to be the exact same as much as possible. So that's the technical term for all of your constants and your controlled variables. Your independent variable, that was your one difference. So your book has a little bit of the older terms. I'm going to just put them up there just saying, hey, as a side note, these are still the new terms that you learned last year. Alright, so did I get theory now? I did. Alright, so look at the top of the page on page number 5. So theory, this is a hypothesis that has stood the test of time at this point to where, okay, not all the way yet, but it's been around for maybe a couple decades, like plate tectonics. Anyone know what plate tectonics is? Chris?
Places that are underneath the earth that allow the earth to shift.
Did you know that that theory's only been around since like the 1950s? So that's after World War II. So that's why that one is still a theory, because it hasn't stood too long. And again,
We know it's fact.
wait, raise your hand. Okay.
It's pretty much fact.
We don't know for sure since we can't go down there and actually see it. So it's one of those, this seems like the best educated guess. It seems based on our experiments, multiple scientists have tested it and tested it with the S waves and P waves. It seems like this is a pretty good idea, but at the same time, you can't go down there and prove it absolutely. That's how come it's not considered a scientific law yet. It hasn't stood quite as long, so it's not even 100 years old yet. So it's one of those, it's still considered a theory, but it's one of those, okay, yeah, we're pretty sure this is how it works. This seems like it's right, but since it hasn't just stood the test of time for longer yet, that's why it's still just considered just a theory as opposed to a scientific law. We have, oh goodness, hundreds of theories. There's so many of them, so many that are around now, and scientists are pretty sure that, yeah, this seems like it's right. Since it just hasn't been proven over and over and over again, or since it hasn't been around for a long time, also they're still just considered theories as opposed to scientific laws now. Scientific laws are reserved for the ones where scientists are pretty much sure of, yes, we can't get any more exact than this. This is as close as we can get. This seems like this is true every single time. Okay.
So technically creation and evolution are three theories?
Yep, you're right, because you can't prove creation because how many times did creation happen?
Okay.
One time, and that was it, and we weren't back there to go observe it. Now, someone was there. Do you know who was there to observe creation? God, and what did God do to tell us about it?
Bible.
Yeah, wrote it down for us. So that's what we know, okay, this happened because God wrote it in his Bible. And that's how come God gave so many details for creation, saying, I made this on this day, and then night fell. And then I made this on this day, and then there was night. Because he's given us details so that way we can know, okay, here's what happened. Now again, they can't prove evolution either because that was a one-time event. And so it's a theory for them. Now, sadly, they believe it just because typically they want to believe something that's not about God. That's typically, there's other reasons why someone might believe in evolution. But that's what that they can't prove that one ultimately either because that was a one-time event. Alright, did you have a question as well, Chris, or was that it?
Isn't technically it's closer foods?
Yes. To put it that way, the plate tectonics, as you have the plates, as they're building up forces against each other, eventually the two plates will shift, typically, and that's what causes earthquakes or tsunamis for it. So yes, plate tectonics in and of itself, depending on where you're at in the world, it depends on the force, but they're basically stuck on each other. Alright, so just making a note of what a theory is. This is whenever you have your hypothesis, once it's passed your experiments and some other guy's experiments, and scientists say, okay, looks like you're right. Okay, we'll take it. That's whenever it's considered a theory at that point. Now once it's been proved over and over and over and over and over again, they don't really find any exceptions to it, and it's been around for a while. And that's whenever scientists say, okay, we'll make it into a law now, or a scientific law, if you want to be exact for it. So that's whenever they say, okay, this has been around for a very long time. It seems like it's right in almost every circumstance. Okay, we'll call it the scientific law at this point. Alright, so the purpose of science, really quick at the top of page 5. Your book is telling you, okay, there's some things with science that you just can't study. So first of all, science properly so-called only deals with the physical universe. Can you cut up someone and find their soul? You did what?
No.
No, you can't. Thank goodness we can't, because that'd be terrifying and scary and bad things would probably happen. So you can't cut up someone and go, there it is, there's a soul. No, we think it's probably in your brain because that's where you think. But I mean, it's spiritual. You can't find that in someone. Same idea where like you can't get up into heaven or you can't get into hell unless you die because that's spiritual. You can't accidentally fall into hell. You can't accidentally go to heaven because they're locked out. They're more of spiritual planes that are not in the physical. Okay.
So do you know on YouTube when people have claimed it, there's movies on have claimed that they've died and gone to heaven and come back? Like from
I've heard stories
do you
about
think
this.
do you think it's true or they should be for attention?
I don't want to, because I don't want to negate someone's experiences for it, because my grandmother claims the same thing, and so I think it's rare, but again, sometimes God may allow them that to happen. Now, I don't think you can like come back to life as like a ghost. It's very, very, very short over how fast your body deteriorates. So it's not like someone can like come back after being dead for like hundreds of years. Okay, that's not how that works. If it's maybe a couple minutes, maybe, I don't know if I would believe like if what they say doesn't match with what the Bible says, believe the Bible first. So if they start talking about what they saw in heaven and doesn't match what the Bible said, okay, now you're just being trippy. Or if what they see in hell doesn't match what the Bible says, okay, now I'm just being suspicious because the Bible trumps whatever vision or whatever people have seen when they thought they died.
What does your grandmother claim to look like?
She didn't see. She said, if I remember correctly, she couldn't describe God very well, just because she said it's just like beyond human like speech, like you can't describe him. Even John said that in the Bible as well. But she said that heaven was absolutely beautiful, like it's just the most beautiful thing you could imagine.
Is your grandmother a Christian?
Yes, and she's already gone on to heaven, so she's already there. Yeah, you can't ask her. Okay. So, just making up though, theory and scientific law. So, for some things, we're stuck in the here and now. We can't go back and test creation because that already happened. It's not here and now. You can't test where heaven is because that's outside of the here and now with the physical. So, you're much pointing out the spiritual, the supernatural, the moral, the human personality. All of this is beyond the realm of science. You can't use science to determine is this right or wrong. Now, people have tried to do that. Does anyone remember what's it called? Remember people tried to breed the best human race in World War II? Now, people still kind of try this today.
Isn't that, I mean, you're trying to play God, but
Yeah.
isn't that like, I don't know actually. I had it.
It's okay, it starts with an E. Do you remember? EU. Yeah.
Euphoria?
What was it?
Euphemism.
What?
Euphemism.
Yeah, it's still not whole people. Very close though. Put it bluntly. Alright, eugenics is whenever you're trying to basically kill people to get proper genetics. Now, they said they had scientific evidence that certain races are more superior or more evolved than other races. And that's how come that they would kill off African Americans, or at the time, like, it was just Africans because they weren't Americans. So, like, it wasn't the American population. So they would try to kill off the gypsies or the Jews specifically. And so that's what they're saying. These people groups are not as evolved, and they had scientific evidence at the time for reasons to say this is why this is okay. Now we say no. We know from the Bible that human beings are human beings. It doesn't matter on your skin color or eye color or hair color or how tall or short you are. You're still a human being. It doesn't matter what science says. You still have a soul and you're still valuable to God. So that's what it's talking about with the idea of right and wrong. All right. The second major thing is that even in the physical universe, science cannot answer all of our questions. Sometimes you're going to eventually get to something and you go, oh, why does it do that? And the answer is, we don't know why it does that. Scientists have tried and they wonder and they just don't know why. One of the major ones is inside of the nucleus, the protons and the neutrons stick together. Alright, you might remember from physical science. Anyone remember what charge the protons have? Right?
Neutron or proton?
Protons.
Oh, they're positive.
They're the positive ones. So you have the protons. They have a positive charge. Alright, neutrons.
Negative.
Nope.
What's the middle? It's not positive or negative. Neutral, yeah.
Neutral. So I guess you were right. But yeah, so the positive part and the neutral part stick together. Okay, does positive and neutral normally attract each other?
No.
No. Scientists do not know why this happens. They don't know why do they stick together. And scientists go, we don't know. They just call it the strong nuclear force because they don't know what else to call it because it sticks together. And it bothers scientists. And it's one of those. Eventually, you just have to go, why does it do that? I don't know. Don't worry about it. It just does. So that's part of it. That's part of what your book is talking about when it says some things you can't answer all your questions. And that's okay. Now, we should still try to study it, but at the same time, there comes a point in time when it just does, and it's okay. Alright, so last thought of the sentence, the science of chemistry is not governed by haphazard or disordered principles, but rather an ordinance that leads to reproducible effects. Those reasons why you can test chemistry and why we do things in chemistry labs is because we know that, okay, if we mix an acid and a base together, you're going to get a reaction. If you mix an acid and a base together and you don't get a reaction, like vinegar and baking soda, then you know something is wrong. I did something wrong. Something's happening with it. Wait, Richmond?
Once you get a reaction, it's vinegar baking.
Oh yeah, no, you're supposed to. So like I said, if you mix them together and nothing happens, you know either this is not baking soda like I thought it was, I thought I labeled it correctly, but maybe not. Or this isn't vinegar, then something's wrong. Yeah, if you use baking powder instead of baking soda, it ain't
I mean baking powder, or baking powder. It
It
won't work.
Yeah, it doesn't work very well.
Baking
It's
soda?
the baking soda
is
the
more,
white
is more,
powdery stuff.
Isn't baking soda like more refined than
They're slightly chemically different. This is one reason why if your mom has ever mixed them up while she's making a cake or cookies and you mix up baking soda and baking powders, they're typically flat because they don't rise properly. It's because they're very slightly chemically different. So that's how come whenever you mix vinegar and baking soda, you mix all the bubbles because you need the bubbles on the inside of your cake to help give it that volume that it needs. Otherwise you're going to get a sad pancake cookie cake and you still eat it. It's just not as fun. What? Yeah, I mean it's still there. It's just flat. It's okay. Alright, so measurements in chemistry. Alright, how do we measure things? So measurements, we use mathematics. I think you had to learn this definition last year. Mathematics is the language of science. You use math in chemistry. It is to help you see how much has something changed. This is one reason why in your STEM projects last year, I made you record it in measurements, not just the soil moved, or not just my plant grew, or not just the, Ethan, I don't remember what you did. What'd you do? Magnetism. The magnet was attracted. So it's to help you measure how much was the magnet attracted. How much did it change with the different temperatures? Now I remember. How much did my soil erode? I made you record in data or measurements. That's because that helps you to think absolutely how much did it change. Not just stuff happened to change. Just to help you see which one worked the best or which one had the most change. Look at the quote by Laura Kelvin on the bottom of the page. Alright, who wants to read that so you can get a chance to read instead? Alright, Chris.
When you can measure what you're speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, it may be the beginning of knowledge, but you have scarcely in your thoughts advanced to the stage of science.
Yeah, so he's saying that, okay, you might know something about it, you have a general idea, but until you can put it in numbers and say it has changed this much, you haven't organized your thoughts, is what he's saying. You know exactly how much you changed, and you can show it to other people, as opposed to the peat soil was the best. I don't remember which one was the best for you, actually. But it's just saying, okay, this one was the best. Which one? Yeah, and so it's just the idea of, you know, okay, specifically this one now because you have data to match it up.
He was the worst.
And then I just couldn't remember off the top of my head. So, alright, so look over on page 6. Accuracy versus precision. I go over this every year because we have to discuss it with the STEM projects, but we also need to know it in chemistry as well, a little bit more detail. Alright, so there are 2 of you, so I can have 2 volunteers unless you choose not to because of Corona. But I will disinfect them ahead of time. Alright, so who wants to go first then?
I'll go first.
Alright, Chris, I'm gonna change the angle so that way Jamie.
Oh, no. So is the target Ethan's ear cup or the
No. Okay, watch out for Ted. Watch out for Fred. Okay, don't throw it.
Fred?
I think Fred, isn't he the muscle one? Sorry.
Yeah.
Yeah, Ted is the.
Ted is
That's
the
the
skeleton
one.
dude, but.
Alright, hang on, I'm gonna shift the camera so that way they can see you.
Fred is more like, that's more of like a guy that would be a little bit thicker, and Ted is kind of a skinny.
Alright, to make it fair, you can stand right here at the edge of the desk. So, Chris, smile at the camera real quick.
What's up?
Alright, now you can throw it at the dartboard. Alright. Okay. Alright.
Break it.
That's accuracy right there.
Is
It hit the same spot every time.
Oh, okay, so is that accuracy or precision?
That
Where you
is
hit the
Precision.
same spot.
accuracy.
Is it?
Precision.
Precision. Because did you hit my bullseye, Chris?
I was not trying.
We're talking about 33 times in a row, by the way.
Do I need to disinfect those?
I'll disinfect them after class. So you get the blue ones disinfected.
Can I go again or are we just going to
Do you feel like you need to go again?
Yes.
Including yourself? I'll let you go again. Take your red darts with you then, since I've already disinfected them last time. We'll let you go again after Ethan. And then Ethan gets to go again as well. Alright, Ethan, wait, smile at the camera.
Hold on.
Alright, right there at the edge, so it's fair. I'm gonna dust back a little bit. Alright. Now you can throw it. Watch out for Ted.
Precision. It's been too
Oh,
long.
hey!
That's
So
20.
you got closer.
It's been too long.
Alright. you wanna smile again, Chris, or Nick? Alright, here's your chance to redeem yourself. Okay. Do you wanna get closer, Chris?
No, I want to get over there.
Okay.
I mean, that was all over the place.
That wasn't precision or accurate.
That was
That's
just
okay.
bad.
Alright, Ethan, do you wanna smile at the camera one more time?
Hola.
Alright. Hey. Getting closer. Okay.
You jinxed
I
it.
don't know if either one of those is necessarily
I am
accurate
better
or
than Chris, though.
precision, but of the two, I think actually Chris was more precise because he hit the
More
same
precise?
spot, but you were more accurate. Alright, so
Me and
if you're
basketball.
looking, I'm moving my chalk. Alright, if you're
I'm always
looking on a
precise because I
dartboard.
always hit air.
Alright, what was that?
I said I'm always precise in basketball because I always hit air.
Alright, so let's say, going over it, of the accuracy or precision, that if you were to hit the same spot, like, for example, for Chris, if you're hitting the same spot on both sides, okay, you were precise, you're hitting the same mark, you just need to shift it over a little bit more, but you do have precision, you are hitting the same spot. Now, if you were hunting, and you're looking through your scope, and you see this happening, what's typically wrong, or what do you need to do to
Scope
fix
is
it?
off.
Your scope's off. So that's what it's talking about with precision. Precision has to do with consistency or reproducibility, and that's what let's come out for this one. That for these you can have random errors because they tend to fluctuate around the true value. If you have a gun and if you're shooting and it's doing like this,
Yours is
that's
bad.
not necessarily the gun's problem. That's
you.
you. That's random errors. It's you at that point.
Someone
You
had-
can fix it. Wait, raise your hand. Okay.
To have that bad of a bull pattern, you have to have Parkinson's.
Okay, maybe not. Let's be respectful of people that do have that disease.
Respectful?
Let's be respectful. But yes, so someone just needs a little more practice. Accuracy has to do with hitting the exact mark over and over and over again.
Chris Conley.
Yeah. So that's one of those to where, okay, you need to get as close to the goal as possible. For these, if you can see that, okay, that you're hitting off to the side, that means that your instrument is typically wrong at that point. For that one, we call those systematic errors that affect accuracy. Typically, if you readjust the scope, you'll be fine at that point. So that's the difference between accuracy and precision. All right, anyone have any questions about those two?
So does that mean my hand's off?
Why?
Because my instrument's off.
I think that's one of those you work on your hand-eye coordination. I think that's
Oh,
what that is. Sorry.
You can't say anything. You almost killed Ted. Twice.
It's okay. Ethan didn't have precision either, but you did get closer to the bullseye ultimately.
Luck.
So it's alright.
Yeah.
Alright, so moving on, accuracy and precision. Alright, exact numbers. These are the two types of exact numbers. So again, just be careful in your homework as you're going over it that you look to see, okay, what exactly am I looking for? So your book talks about with uncertainty. Numbers should be numbers attained by counting are usually certain. Like I can count the number of desks in here, and I don't have to wonder how many desks I have. Which, as a side note, does anyone know how many desks I have?
30. No,
15.
15. So 15 desks in here. How do you know that there's 15 and not 30, Chris?
Because math.
Alright, so you typically probably went, okay, 3 desks in a row. I have 5 rows.
I did
15.
5.
I did 5 and then 5 and 15.
Yeah, that's fine. 12 for this idea, you don't have to wonder, do I really have 16 desks? Do I have 13 desks? No, you know I have 15. Like I have,
you do have 13 desks,
wait,
but
hang on.
you-
I'm not calling you it. So, because of that, you're saying, okay, I have 15 student desks if I want to be technical for it. And yes, I have 2 teacher desk structures as well for it. Alright, now how many students do I have? Ethan?
4.
Oh yes, total. How many do I have in this class?
2.
Physically with me. Yeah, I don't have to wonder, do I have 2.5 students? If I have 2.5 students, I have a problem, as a side note. But I don't have to wonder, I can count. You can count the number of light fixtures in my room. You can count the number of tiles in the ceiling. Don't bother doing that right now, because it'll take you too long. But it's the idea of just saying, okay, you know how many there are. You don't have to wonder how many does she have. She can count them. You're not going to listen to anything I say if you distract me
77.
counting my tiles.
It's 77.
77 tiles?
Mhm.
You got them all, you sure?
Mhm.
I'll check. Alright, so that's the idea of examiner. Defined values, these are based on their
What was
definitions,
77?
like how many inches are in a foot, Chris?
12.
Yeah, alright, now how many centimeters are in a meter? Went over this earlier.
100.
100. You don't have to wonder, does this foot only have 11 inches? No, based by definition, a foot has 11 inches. So you don't have to wonder how many are there. You know what that means. So that's the idea of exact numbers. If you can count it, you know how many there are, and it's a defined value based on the definition, you know how many there are. Like how many days are in a week, even.
7.
That's not a number. Alright, how many?
7.
7. Alright. Alright, who decided that there's 7 days in a week?
God.
Yeah. And you know people have actually tried that in history to give different days into the week, and it doesn't work out well. So people have traditionally decided, we'll just leave it this way because it seems like it works the best. So that's like a defined value. God said, hey, you want to have 7 days in a week, this works out best. And people have traditionally followed it. Alright, different types of systems of measurement. There are 3 basic ones. So, systems of measurement, you have the FPS system, the metric system, and then the more exact version of the metric system, the International System of Units. Alright, the FPS, or the foot pound second system. There's only really one country that uses this one. Anyone know which country that is? Eden?
Oh, America.
America, because you're basically too stubborn to give it up. There's a couple of other countries that do it with us because we do it, but that's about it. So foot pound second system, this is the one that is traditionally used in America because we're just too stubborn to basically give it up at this point. This is one reason why milk is sold in a gallon while you have soda being sold in 2-liter bottles. It's just because Americans say, no, I really want my gallons. Okay, that's fine. So that's probably the reason why. So foot pound second system, this is just for Americans. There's some other countries, I think there's like 2 others that do it with us, but that's about it. They come from English metric systems, how the English traditionally measured it, or the Romans. Some of ours, they're actually going to compile together. But this one is just for Americans. It's not very scientific, just because it's based more on traditional measurements and not scientific measurements. This is why we don't use this one in science. Plus, the rest of the world decided to use the metric system, and we decided, okay, well, if y'all want to use it, fine. But we're not giving up ours. We're keeping ours too. So that's how come we have 2 in the United States. But for science, we use the metric system. Technically, we use a more advanced version of it. So this is the metric system. This one is used worldwide as a system of measurement. Like, does anyone know what you typically cook at in the United States, what your ovens, what temperature scale that you use? Okay? Fahrenheit. That actually throws off a lot of people because if you use an English cookbook or a cookbook from another country, it typically means Celsius. So you will either burn your food, typically, yeah, or they don't know what they're doing because they assume it's in Celsius too. So, raise your hand, Ethan. Yep.
I don't know what Kelvin is.
Yeah, Kelvin is for science, and don't worry, we'll talk about Kelvin in just a second. Okay.
Yeah, no, I said Kelvin. He's like, I don't know Kelvin.
Alright, but yeah, no, we'll get to it. But those will come in other countries, they use Celsius to cook up. Well, we traditionally use Fahrenheit. So, just making another metric system, this is used for what is a standard system of measurement. They're based off the gram, the meter, and the liter as their main units for measurements. We'll talk more about them in just a little bit. Now, in the 1960s, they decided that we're going to make a more exact version of it. Now, your book gives you the French name for it as well. You don't have to know it. But it's the International System of Units is how it comes out in English, or the SI system. And French is the Système International des Units. It also comes as SI. Well, we would say it as IS. Just make a note, okay, everyone else says SI, so note that as well. This system is very SI. It's a modification of the metric system where everything is meticulously defined for science. So these 2 are basically the same, but this one is considered the more exact version, so that way it's more scientific. So do make a note of these 3 systems of measurement. FPS system, this one's just for Americans. Metric system, rest of the world. And the International System of Units, or the SI system, this is the one we use for science in particular. Alright, so the metric system, or the SI system, they use these system of measurements, or those prefixes, to help them describe how many of a unit makes up a larger one. Like if you have a kilometer, or a kilometer, how most people say it, how many meters are in 1 kilometer? Anyone know? Okay. How many? 500. 1,000. So it's 1,000 meters are in 1 kilometer. So look at the prefixes at the top of page 7. Now, as a side note, you note this table really well, really soon. That's why I mentioned yesterday. You might want to start memorizing it. You need to know it by like tomorrow. So you should start memorizing. Yep, tomorrow. So be ready. Start memorizing. I'm just saying. You probably need to know it. All right, wait, hang on. Okay, what was your question?
Why are some of them negative, like 10 to the negative?
That means really small number, so it's a small chunk for it. So if you're looking, like, let's say, we'll start towards the middle of it. So, centi, like that means 100. So if you have a centimeter, that means you're taking a meter stick and you've chopped it up into 100 pieces. So individual centimeters, they're a little bit smaller than an inch. So that's the idea of, okay, you have in a meter stick 100 centimeters. You do need to know the name, the little symbol for it, what it means. So 100th, that means that you can chop it up into 100, that there's 100 of these that make up the meter. So if you have a centimeter, there's 100 of these little bitty centimeters in 1 meter stick. Okay?
We have to know all of them?
No, just the bold ones. So that's a little bit better. So centi means, has abbreviation C, 100, or it's 10 to the negative 2. So that just means that, let me just raise into the negative 10 to me, to the negative second or the negative cube power, just describing it to you. And it shows it to you decimally what it looks like. So you want to know what nano is? That's 1 billionth, really, really, really small. So if you have a nanometer, you've taken a meter stick and you've chopped it up into 1 billion pieces. So each one is very, 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 very tiny. Okay.
Do we know prefixes as well?
So like if you're looking at nano, because that's the first bold one on this chart. So nano, you want to know the prefix. The N, you want to know 1 billion, and you want to know it's 10 raised to the negative 9. And then you don't have to know the numerical value after. You don't have to know it's like 0.000000001. Just note it as, okay, it's 10 to the negative 9th, and that tells you how many zeros are in the decimal point. But it's very, very, very small. Micro has a weird symbol. It's kind of like an upside down H with an extra little like tick on the end for it. So micro, 1 millionth, 10 to the negative 6. Milli, 1,000th, has an M, 10 to the negative 3rd. Centi, 100th, 10 to the negative 2nd. You got a question, Ethan? Okay, make sure you're raising your hand, because I keep hearing murdering, and that means that Jamie and Quentin can hear it much better than I can, so make sure you're raising your hand. Alright, so deci, deca, and hecto, those aren't folded, so you don't have to know those. But kilo, K, 1,000, so 10 to the positive 3rd, because it's telling you that there are 1,000 or 10 cubed meters in one kilometer, or kilometers, how much people say it. And then mega, capital N, 1 million, and 10 to the positive 6. So this is how the SI system and the metric system uses these to help describe it. It's not like the idea of you go from an inch to a foot and you've changed the whole term. It's the idea of, okay, you still have a meter, but it might be a centimeter. Or if you're going larger, it'll be a kilometer or kilometer. Okay, so what's your question?
What is the symbol called for micro?
You're going to ask me that. I don't remember off the top of my head. I'm sorry. I'm pretty sure it's the Greek one. I just don't remember what it's called. I'm pretty sure it's Greek, like alpha or beta, but I can't, like, that's not alpha and beta though, and I don't remember off the top of my head what it's called. What?
Delta.
Delta is the triangle.
Oh.
So I just don't remember what this one is. No, I'm sorry, I forgot to look it up. I'll try to remember to look it up tomorrow, or you can look it up yourself, that's fine. Alright, so just make a note now. So nano, micro, milli, centi, kilo, and mega. So, anyone have any questions about them? If we have time at the end of class, we can play a review game with them if they'll come. I just want to make sure you don't have any questions about them. Because really, this is the best way to learn them. Alright, so measuring length and volume. There are some units or some measurements that are always used. Like if you're measuring length of an object in the FPS system, you might use a foot or a yard or an inch. In the metric system, we only have one type of unit that we use. What is that type of unit, Ethan? If you're measuring length of something in the metric system or SI system. If you're going to measure a length, you don't use a yard or a foot. What are you going to use?
Ruler.
Okay, what type of ruler?
A ruler, school ruler.
Okay, that is what type of ruler?
School ruler.
Oh no, Chris.
Meter.
Meter. So mark that one. The SI standard of length is a meter. So if you're talking about length, you will never use gram or liter or something else like an amp. You will always use meter as we're talking about the SI system. So if you see a word problem and it asks for meters, what are you finding then? Okay, yes. But then also, like, what property?
Length.
Length, so that's it. So you're always going to use meters and length. That actually threw off a lot of students last year. As they would ask me, what am I finding if I'm finding meters? What do you think you're finding? Length. So make sure that, you know, if you're finding length, you're going to be using always meters. If you're finding mass or kind of loosely weight, you will always use grams or kilograms because that's the same unit, just one's larger than the other. Alright, your book talks about just about kilograms and grams on the next page. You can go ahead and go over there. Alright, so do make a note of what a liter is for volume. Now, you can think of it as like soda. Your soda is sold in 2-liter volume containers. That's because the soda is a fluid, so that's how come they put it with volume as opposed to mass. So if you're finding volume, you will always find it in liters. Maybe milliliters, because it's really small, but always liters. If you don't have it in liters, sometimes you will find it in centimeters cubed. So I'll write that one on the board. Sometimes you'll find it in centimeters or centimeters cubed. That is another version of the same thing. Technically it's a milliliter, but it's something where, okay, you see these interchanged. But if you see grams, that's not volume. Okay.
The only one that finds it kind of ironic, they have Coca-Cola next to someone that's lifting weights.
They're trying to show mass versus weight,
Yeah.
measuring volume and stuff. They're showing technically a sugar cube next to it as well, technically. Because a milliliter is the same cubic centimeter as the volume of one little bitty. If you've ever seen a real life like sugar cube, that's about the same size
They
for
feed
it.
the horses.
Yeah, they still do that.
What do
Or
they do?
what?
What is it? Is it good for them or something?
It's like
Like a treat?
yeah, it's a treat. Like you shouldn't like just feed the horse just sugar cubes. Which one of those? Okay, it's a healthy snack that you can give them, but you should give them something like chocolate, like that or something. So sugar, like that form is fine. All right, measuring mass. Mass, keep in mind, is the quantity of matter in an object. I think you've already talked about what matter is. Anyone remember what matter is? Okay, Chris.
Everything that has weight, or is you can touch.
Okay,
Or see it.
yes. So if
Even
you can
food
interact
ones.
with it, yeah, in the physical world, like you can taste it, taste it, touch it, interact with it,
I
then
said-
that, wait, hang on, let me finish my thought, and then I'll call you. This is whenever, okay, it's part of the physical world. Okay, now finish your thought.
Last time I said literally everything that was wrong.
It's okay. Because remember, not everything, because light technically is energy. Technically. I mean, it's made up of itty bitty photons, but technically it's energy. Alright, weight is the force of gravity on the object. So, if you were to go up to the moon, would you weigh more or weigh less? Okay, why, Ethan?
Gravity.
Okay, well, the moon has gravity. Earth has gravity.
Because God said so.
Okay, no. Okay, Chris. I mean, yes, God said so.
The
I mean,
gravitational pull is less on the moon.
good job. So, the Earth is the most massive thing on Earth because it's Earth. I know.
Wait,
There's
what?
no other better way to say that. That's how the Earth pulls everything towards it, pulls you towards. This is why if you were to accidentally spit out your water, the Earth pulls it towards itself. It's not going to just start just hovering in the air. The Earth says mine, all of it's mine. It is the most massive, or it has the most mass of anything else around us. That's how come it even pulls the moon towards it and it locks it in that orbit. Because the moon is smaller mass size than the Earth, so it's because the Earth it hangs on to the moon and pulls it towards it. Now, if you get close enough to the moon, since the moon is closer to you at that point, the moon can pull you towards it. That's like astronauts. They could kind of walk up like that bouncy step on the moon because there was less pull or less gravity pulling them down. So their weight was slightly different or slightly less on the moon. Now it's not like the astronauts lost mass. They did not like chop up an arm or change their body some way when they went to the moon. Their mass was the same. Just the gravitational pull of the moon was weaker because the moon itself is smaller. Alright, Luke, you have more thoughts?
Yeah, because I mean, the gravitational pull is also why some moons can have moons.
Mm-hmm. Yeah, like
was it Jupiter that has a moon that has a moon?
Jupiter and Saturn have so many moons, both of them. I think Jupiter I think has like 16 or something. Saturn has a bunch of them. Pluto is technically smaller than its moon, but I believe it has more mass to it. So because of that, they kind of like spin around each other. So that's like how people like said Pluto's a longer planet because it's too small and other stuff for it. So that's probably the
But
reason for
it's
it.
not a moon because moons technically don't have an atmosphere. And Pluto has an atmosphere.
Alright, we'll have to talk more about it because we're running out of time, but that is cool for it, and I miss Pluto at being planet. Alright, so weight is the force of gravity on an object, so just make a note for that weight technically is gravity that pulls it down. Mass just refers to how much matter you have in an object. Alright, so your book gives you, I'm giving you that the main unit that we use is the kilogram. Because we're working with chemicals, we're not going to measure out a whole big kilogram of a substance. We use typically grams. So grams or kilograms, the same unit measurement. We did different prefixes to describe how much we're going to use it. Alright, your book gives you the old definition of a kilogram. A kilogram used to be described based off the special cylinder stored in Paris, if I remember correctly, because the units of measurement, meter is used for length, liter is used for volume, the kilogram used to be based off this special cylinder. They decided as of last year that this was not a good unit to use anymore for it, so they have a more exact definition. You do not need to know the exact definition for it. But on May 20th of 2019, the definition of the unit of mass had changed. For a kilogram, they said the mass of a kilogram is a defined number of photons, which are little bitty light units. That is 1.4755214 times 10 to the positive 40. That's a really large number. At the frequency of the cesium atomic clock, this is a much more complicated definition. But it's that they have an exact weight of a kilogram now. So again, you don't have to note that, but I'm just telling you that it's not based on the cylinder anymore. You probably learned that last year or 2 years ago with physical science. So just make a note of, okay, it's not based on this. So you can like mark out that whole paragraph in your book if you want to, because it's not based off the actual cylinder in Paris. But it just hasn't been updated yet as of the last year. Alright, really quick, getting into it. Density. Here's your first equation that you need to know. Anyone remember what density is? As a side note, your book tells you very quickly for it. Alright.
Density is like how thick something is, like and how much you fit in one space.
Yes, so I use this in junior high and in my younger classes to help describe volume and density. So right now, does this have necessarily a lot of volume? Does it take up a lot of space?
No.
Not really. Okay, does it have a lot of, is it very dense though? Yes, because all of it is compact together. Now if I were to let it open, okay, does it take up a lot of volume now even?
Yes.
Alright, is it very dense?
No.
Not really. So that's the idea of the opposite for it. So density refers to how tightly packed together matters. This is one reason why once you fit everything into your carry-on suitcase that you're taking on the plane as much as possible, typically it's really heavy because you have fit the maximum amount of stuff on the inside of that suitcase, or at least I did when I was bringing on my carry-on. Okay.
When I was younger, like before I got stuck in one of those things,
That's
like
rough.
when they were tighter than they are now, because I guess it was a safety hazard.
It does hurt if you let it close, because I've had kids be like, can I put it on my head? No. It's a really bad idea. But, you know, I mean, I did that as a kid just to see what happens. And
It doesn't feel good.
No, it doesn't feel good at all. Alright, so density, here's your first equation that you need to know for it. I couldn't make it look very good in my PowerPoint slide, so sorry, so I tried. So, it's not P, it's the little symbol rho, so it's the Greek letter, and it looks basically like a P, but go ahead and make it work. As P is mass over volume. Now this is a very basic equation. You've seen equations like this before, where you probably realize, okay, I think I know what I'm doing this. So remember, the M stands for mass. So if we're talking about mass, what units will we probably be using? Chris? Kilograms or?
Kilograms or liter? No, that's liter.
Okay, so kilograms is, okay, kilo means 1,000, so what's the other part of it? Grams. So we use either just grams or we use 2,000 kilograms for it. Now volume, if you're using volume, what units are you probably using? Even? Liters. Or some cases like for this one, we actually use the centimeters cubed for this one. Alright, we'll go ahead and we'll stop there. Alright, number 49, study the chart. Study. No promises for tomorrow, but definitely know and be ready just in case. Alright, so read pages 8 to 10, answer on page 10, chapter review number 4, and application number 1. So read pages 8 to 10, answer on page 10, the chapter review number 4, and application number 1. And study the table on page number 7. You want to know the bold terms. Okay.
8 to 10.
Alright, 8 to 10, read it. And then you're going to answer on page 10, chapter review 4, and application number 1.
How big is the review for? Is it 1?
Like it's concept review, that problem number 4.